Okay, I'm going to go through the MCQ paper 1 of the 3NA Science Physics 2017 end of the year. So let's start off with question 1. So question 1 says, which of the following quantities is equals to 0.000005 seconds? So this is actually a prefix, okay, that must make the thing smaller. So mega, okay, so let's go through. So giga is 10 to the power 9, so it actually makes the number bigger. This is giga 10 to the power 9, this is mega 10 to the power 6, nano is 10 to the power minus 9, this is micro, which is 10 to the power minus 6. So you can see here, this actually is a smaller number, so therefore B and A is out. Whether should I use micro or nano, look at number of zeros, 1, 2, 3, 4, 5, 6, so 10 to the power minus 6, so therefore answer is C. Right, so question 1 is a smaller prefix, it's a prefix that makes the number smaller, so therefore mega and giga is out. You need to find something that's 10 to the power minus something. Next, because there are 6 zeros, so therefore it is 10 to the power minus 6, which is micro. Next one, a micrometer is used to measure the thickness of 10 sheets of paper. So these 10 sheets are. Okay, so what we can have here, this is a micrometer, so I need to find the main scale reading, the thimble scale reading. Okay, so main scale is 0, 0.5, 1.0, 1.5, 2.0, 2.5, 3.0, 3.5, 4.0. So the main scale reading is 4.0 mm. The thimble scale here is 20, 21, 22. Okay, so 22, so 0.22 mm. So the micrometer screw gauge reading is actually 4.22 mm. That's for 10 sheets. Now what they want is the thickness of one sheet of paper. So therefore I must take 4.22. So one sheet is equal to 4.22 divided by 10. So 0.422 mm. So answer is A. Next one. The graph shows the speed time graph of a car. Which statement about the motion of the car is correct? Which statement is correct about the motion of the car? So the car is moving at constant speed at P. Now at P, the car is not even moving. So no constant speed. The car is decelerating at Q. Now, decelerating means that the speed is decreasing. If you look at here, do you realize the whole graph, the speed is actually increasing throughout. So therefore, B is also wrong. The car is moving at constant acceleration at R. So this is a speed time graph. The gradient will give you the acceleration. So if we got the gradient, there's a straight line, which means there is a constant gradient, which means there is a constant acceleration. So therefore C is the correct answer. The car is decelerating at S. Decelerating means that the speed is decreasing. So this is also wrong, because the speed is not decreasing at all. So there. Okay, so that's for question 3. Question 4, which of the following quantities are all vectors? So under your chapter 2, okay, you will talk about vectors and scalars. Okay, so you need to remember them. Take note of all this. Velocity is a vector, mass is not, acceleration is. Velocity is, speed is not, force is. Weight is a vector, acceleration is a vector, time is not a vector. Weight is a vector because it's a force, velocity, yes, force, yes. So answer here is D. So this one is either you know or you don't know, because all this is in chapter 2. So go and remember them. Next one, the figure below shows a man supporting a mass of 20 kg suspended from a rope without moving. So it is not moving. So if it's not moving, means that it's at equilibrium. So if it's at equilibrium, which means that the resultant force is 0. So therefore, the answer here is A. So key idea here you need to pick up is not moving. So once from not moving, you must know that it's in equilibrium. Once it is in equilibrium, you know resultant force must be 0. Okay, so what's the resultant force? Answer is 0. A force is applied to an object on a frictionless surface. It produces an acceleration of 4 meters per second square. What are the possible values of the applied force and the mass of the object? So this one is test U, F equals to ma. So they say acceleration is 4. So I rearrange this. F actually equals to F over m. So I need that when I take the F divided by m, I should get the value of 4. So this 2 divided by 4, and I will actually get 0.5. So yeah, let me write a column here. A will actually be 0.5. Therefore, this is wrong. 2 divided by 8, I get 0.25. And wrong. 6 divided by 3, answer will be 2.0. And wrong. 12 divided by 3, I get 4.0. Yes, so D is the correct answer. So the key idea here is to manipulate the formula. Know that first you use F equals to ma. Since acceleration is 4, you just take the force divided by the mass to find out what the acceleration is. Once the acceleration is 4 meters per second squared, that is the answer. Which of the following units is used to represent gravitational field strength? Normally we will use Newton per kg. So therefore answer is C. Question 8. The table shows the dimensions of 4 rectangular blocks which are made of the same material. So same material means same density. Yeah? Which block has a mass that's different from all others? So if they're the same density, we want to find mass. So density equals to mass divided by volume. So therefore, to find mass, I will take density times volume. Since the density of all of them are the same, I just need to find one of them that the volume is different. So length times breadth times height, this is 8 cm cubed. 2 times 2 times 2, 8 cm cubed. 8 times 1 times 1, 8 cm cubed. 4 times 4 times 1, 16 cm cubed. So you realize for D, the volume is bigger. With a bigger volume, but with the same density as the rest, you realize the mass of D is bigger than the rest. Okay, next. What is the property of a solid? They always fill their container. Nope. This is actually describing liquid and gas. They are incompressible. That means I cannot change the volume of solids. Yes, so therefore B is the answer. Solids can flow? No. Okay, only fluids can. And what exactly are fluids? Fluids are liquid gases. They have molecules in random positions. What exactly is molecules in random position? No, the molecules are actually held in fixed position and they are vibrating in fixed position. So therefore, D is also out. Answer left is B. Question 10. Two states of matters are described as follows. Very far apart. Obviously, this is gas ready. Move very quickly at random in straight lines until they hit something. So this is actually describing gas. State 2. Quite closely packed. Move about randomly. No fixed position. So first one is gas. This second one, because of the no fixed position, I know is liquid. So therefore answer here is, question 10 is A. Next one. To make a toast, a slice of bread is placed under a red hot electric grill. How does thermal energy reach a slice of bread? So if this is hot, if I want to talk about conduction, there must be a conductor in between us. So actually, if I want to conduct the heat from electric grill to a slice of bread, I need them to be in contact. So conduction actually is not the main mode here because the bread and the grill is not touching. And in between is air. Air is a poor conductor. So therefore, the main mode wouldn't be conduction. How about convection? Would convection work? Now, if this electric grill is hot, it actually will heat up the air will rise, the cooler air on top will come down. So you actually cause the air on top to circulate and get heated up. The air at the bottom wouldn't be able to do something like this because hotter air generally will rise due to its lower density. So convection, nah. The only other way is how the thermal energy from the grill reaches the bread is really because of radiation. So 11 is actually mainly radiation. Next, question 12. Two plastic cups are arranged as shown in the diagram. Hot water is poured into the inner cup and the lid is placed on top. So I got a hot one here and the lid is placed on top. Which of the following statements is correct? So I got hot water, small air gap, small spacer, so it's not touching. There's a lid over here. Okay, which of the following statement correct? Heat loss by radiation is prevented by a small gap. Nope. You can't prevent radiation. Radiation actually can pass through all the various mediums. So A is definitely out. No heat passes through the sides of either cup. That's not true. Because of the air here, actually there's conduction. Again, it can actually conduct heat out. It's just slower. Okay, so the word no actually is wrong. It's only very little. Next one, C. The bench is heated by convection from the bottom of the outer cup. If this is a hot object, Convection actually requires you to have a convection current like this. So in actual fact, hot stuff will actually heat up the thing around it or at the top. Okay, convection will actually cause things at the top of it to be heated up due to its density difference. So convection happens here. Therefore, is the bench heated by convection from the bottom? Bottom, answer is no. Last one, the lid is used to reduce heat loss by convection. Answer is yes. Because the air cannot escape, so the air only inside here will get heated up. Okay, it will not interact with the air above it. So the lid actually reduces heat loss by convection. So answer is D. Which of the following differences between boiling and evaporation is wrong? Boiling is fast, evaporation is slow, so this is correct. So it's not wrong. Boiling needs external, evaporation do not need, so this too is also correct. Boiling takes place all over the liquid, evaporation takes place only at the surface, that's correct. Boiling takes place at all temperature, evaporation takes place at room temperature. Answer is wrong, wrong. Boiling takes place at a fixed or constant temperature, whereas evaporation occurs at any temperature. So therefore answer, which one is wrong? It's actually D. Question 14. Which of the following? The following shows melting at boiling point of 4 different elements. Okay. Which element is a liquid at -40? So take note, what normally for this kind of question to do, I'll draw a line like this. Now anything above the boiling point, actually the substance is a gas. Anything below the boiling point but above the melting is a liquid. Anything below the melting is a solid. So the next part is really to find out where is -40. So -40 is over here. So at -40 degrees Celsius, aluminium is a solid. How about -40 over at here? So chlorine, -40 is actually here. Because it's lower than -35, but it's higher than -101. So chlorine is a liquid at room temperature. So therefore at -40, so answer is actually B. Iron, -40 degrees Celsius is here. Mercury, -40 is also here. So therefore the only answer possible left is B. B, chlorine is a liquid at -40 degrees Celsius. Next, question 15. A navigation buoy on the sea oscillates up and down as a wave passes. In exactly 2 minutes, 6 complete waves pass by. So 6 minutes, in 2 minutes, I get 6 complete waves. So what is the frequency of the wave? So first thing, let's find the period, because I'm going to use F equals to 1 over T. If I can find the T, which is period, I can find F. So what exactly is period? Period is the time taken for one wave. So I'll take 2 minutes, which is 120 seconds, because it's 2 times 60. And let's just write here 2 times 60, convert to seconds, divided by 6. So each wave is 20 seconds. So the period is 20 seconds. So therefore frequency is 1 over 20, which means 0.05 Hertz. So therefore the frequency is actually 0.05 Hertz, which is A. So this one, how to do actually is to find the period first, thereafter find the frequency. Okay, question 16. The figure shows the cross-section of a water wave. Okay, so water wave, you cut it, there's a cross-section. 3 cm is like this. What is the wavelength and the amplitude? So first thing, find the wavelength first. Wavelength is the length of one complete wave. So this 3 cm is for 2 waves. So one wave is actually 1.5. So these two are wrong. Amplitude is the maximum displacement from the rest position. So 3 cm is from the bottom all the way to the top. The rest position is in the middle. So therefore, the amplitude is actually only 1.5 cm. So answer for this whole thing, 16, is actually A. Next, question 17. A longitudinal wave travels in a direction as shown. A particle of the medium lies in front of the wave. Which of the following shows the movement of the particle? So for longitudinal, the vibration of the particle, or the movement of the particle, is parallel to the movement of the wave, parallel to the direction of the wave. So if the wave is going towards the right, the particle will be moving left and right. So therefore answer is B. Okay, because this is parallel. Next, question 18. Which of the following waves has the longest wavelength? Longest wavelength, I need you to know that it must be radio waves. So this one is, you need to remember lah. Okay. Now, radio wave longest, but down here no radio waves. So what do I need to know? Let's remember the sequence first. So radio wave, microwave, infrared radiation, visible light, ultraviolet, X-ray, gamma ray. So radio waves have the longest wavelength. Obviously, then gamma must be the shortest. So if I compare all of this, next one, after radio waves is the longest, the second longest will be microwave. So all this, C will have the next longest wavelength compared to radio wave. The police siren, okay, so question 19 now, the police siren emits two different sound P and Q. These are produced alternately. The diagram represents the sound emitted. Which sound is louder? So louder means higher amplitude. So I would expect my wave to look higher. So therefore P is louder. Lower pitch. Lower pitch means lower frequency. Lower frequency means the wave is more spread out. It's less compact. Okay, less compact, more spread out. So therefore answer, if I look at motion more spread out, P is also more spread out. So answer is A for question 19. Last one, question 20. An echo sounder of a ship, echo sounder, so most probably this is talking about echo already, indicates the depth of the water below the base of the ship. Echo sounder indicates the depth of water below the base of the ship is 600 meters. The time interval between the transmitted sound and the signal received is 0.8. What's the approximately speed of sound in the sea? Whenever you got such echo question, it's always important to draw the diagram. Okay, sorry, this one, let me draw here. So you need to draw the diagram. So let's draw the diagram out like this. There's the bed. So imagine the device is here. So I send the sound down. I let it come up. How long did this take? Is 0.8 seconds. Okay, 0.8 seconds. So what was the distance traveled by the sound? So distance traveled by the sound in 0.8 seconds is actually 600 times 2. So it's 1,200 meters. That's the distance traveled by the sound because it went down, went up. I want the speed of the sound. So speed equals to distance divided by time. The distance is 1,200 meters. Okay, 1,200 meters. The time taken for it to go down and come up to travel this 1,200 meters is 0.8 seconds. So therefore, my answer will be 1,500 meters per second. So answer for question 20 is D. So those of you who didn't draw, most probably you get it wrong because you can't really imagine or picture it. Or for those of you who can, then that's good lah. Okay, so that's the end for question 20, which is the paper 1 for 3 and 8. If you've got any questions, please feel free to approach me to find out, to just really ask more about it, so you can know what to do. Okay, that's all from me. That's all.